Learn how to use the bytes per element property to find out exactly how many bytes of system memory a single number occupies within a given typed array type. In standard JavaScript, you don't usually have to think about computer memory because the engine manages it automatically behind the scene. But for typed arrays that are built for extreme performances, they lay out their data right onto system's raw memory. And the byte per element constant is a property built in that can tell us exactly how much byte space a single value takes up. So let's look at an example that can help us determine the number of bytes that an element takes up in our typed array. So I'll come into my script section, and inside it, I'm going to create an integer 32 array, since this is what we want to do, that contains 10 slots. And I'm going to go ahead and make it my array equals to new integer 32 constructor, and I'll pass in the number of slots into it. Now that I've done this, it is now time to read the memory footprint of each element of the array. And now, am I going to do that? Well, I'll make another variable and let me call it bytes used. And inside it, then I'll pass my array and then the bytes per element constant, which is also a property. And now I can go ahead to display the results. Document that gets elements by items. Then that's inner HTML equals. Now, what is the bytes per element? You can look at this property that we are making use of here. The byte per element is a static read-only property available on all types array prototypes and constructors. And its purpose is to help output an integer representing byte size. A byte itself is made up of 8 bits. So therefore, its 32 array requires 32 divided by 8, which is going to be equals to 4 bytes per element. So an integer 16 array, for example, requires 16 divided by 8, which is going to be 2 bytes per element. So I'm going to now go ahead and then output the memory footprint of each element in the array, and I'm going to pass in my variable name, bytes used. And on the screen, you should see 4. So this example is checking the bytes per element of integer 32 array and returns the number 4. So this means every single number you add to this specific array consume exactly 4 bytes or 32 bits of hardware memory, which means that if our slot is increased from 10 to like say 15, each element of it will still use 4 bits in the memory. So this is the usefulness of how you can use the byte per element property to determine or find out the memory footprint of each element that makes up your typed arrays in JavaScript. So just as I explained about how you can use how you can calculate the memory by using an instance for the int32 array and int16 array, where I say an int32 array requires 32 divided by 8, which will give us 4 bytes. Now, if I want to ask that, why do you need to calculate bytes? Can't the browser just do it? Well, of course, you can always do that, like I just demonstrated here. But the property is critical when dealing with raw binary blocks called array buffer. So when it comes to array buffer sharing space, for example, if you are reading data from a file structure or network string, you often need to calculate total byte offset manually to move the memory pointer accurately. So an example like this is the usefulness of this particular property when it comes to getting to know the memory footprint of each element in your typed arrays.